The first successful production of live young by embryo transfer was performed in rabbits in 1980s. Rabbits were used extensively as research models in the field of embryology throughout the end of 19th century and the early decades of the 20th century. Successful transfers of rat and mouse embryos were initially performed in the 1930s. Early efforts of embryo biology of large animal species also began in this decade. The first successful transfer of sheep, pig, and cattle embryos was reported in the early 1950s. Surgical transfer of embryo into the uterus of the recipient was the most successful technique used in the early days. Birth of cows and pigs following non-surgical transcervical embryo transfer were reported in the early 1960s.
Most of the applicable embryo transfer technology was developed in the 1970s and 1980s. However, the history of the concept goes much further back. Embryo transfer was first performed and recorded by Walter Heap in 1890. Yes, he transferred 2 Angora rabbit embryos into a gestating Belgian doe. She went on to produce a mixed litter of Belgian and Angora bunnies. Embryo transfer in food animals began in the 1930s with sheep and goats, but it was not until the 1950s that successful embryo transfers were reported in cattle and pigs by Jim Rowson at Cambridge, England. The first commercial embryo transfers in this country were done in the early 1970s. Initially, embryos were recovered from valuable donors and transferred to recipient animals using surgical procedures. It was not until non-surgical methods were developed in the early 1980s that embryo transfer exploded in its popularity. So, with embryo transfer, essentially gonadotropin from the pituitary of sows and boars are injected twice daily for 4 days into the cow. And the target organ for these pituitary extracts, or follicle stimulating hormone, is the ovaries. It's what makes a sow have a litter of pigs. The amount of follicle stimulating hormone circulating normally in a sow makes the ovaries, the target organ, grow multiple eggs. Therefore, the sow ovulates 10, 12, 15 eggs. The boar breeds the sow, or artificial insemination fertilizes those eggs, and ultimately a litter of pigs result. Well, the same thing happens with a cow, except we don't let the embryos stay in the uterus and go to term. In the cow, the uterus is only meant for one fetus, maybe two. They're fertilized with either frozen thawed semen or semen from a natural mating by a bull, and the cow develops one embryo all the way to term. But with embryo transfer, again, the follicle stimulating hormone is injected from a sow. It's a preparation from a sow's pituitary, is injected twice daily into the cow for 4 days. At the end of that 4 days, the cow's ovaries have responded just as if she were a sow. They ovulate multiple eggs. At that time, frozen semen is thawed and artificially inseminated into the uterus, where the sperm makes its way to the fallopian tube, fertilizes the multiple eggs, turning them into embryos. But the embryos, remember, in the cow, there's not enough placental area for the placenta from multiple embryos to attach to the uterus. It's a different type of placentation. So what happens is that we have to wash or flush the embryos out 7 days after the fertilization process or the artificial insemination. The embryos at that time are encased in an eggshell called a zona pellucida. The embryo is literally free-floating in the uterine fluids and is easily accessible through non-surgical flushing techniques. The solution that goes through the cow to flush the uterus is run through a filter. The filter is 50 micron mesh. The embryos, being about 120 to 150 microns in diameter, don't go through the filter. The filter is rinsed into either a round or square searching dish, and there the technicians find the embryos and place them in a smaller holding dish. The embryos are then graded and either loaded into straws and transferred fresh into recipient cows, or the embryos are prepared for freezing. The freezing process is about an hour and a half long and is very similar to freezing sperm. The embryos have to be dehydrated so that intracellular water molecules are not frozen, which creates crystals and creates tissue damage. Instead, they are dehydrated with certain chemicals that dehydrate the embryo. They are then frozen and stored in liquid nitrogen to be preserved for any number of days, months, or even years, or even decades. But let's talk about the recipient cow. You can't just get any old cow out of the pasture at any time of the month and drop the embryo in her. If you do, death is imminent for that embryo. A recipient must be prepared. The reproductive tract of that cow has to be in synchrony with the growth of the embryo. Let me describe that. Normally, when a cow has an estrus period, her normal hormone profile is high in estrogen and low in progesterone. Okay, and when fertilization occurs, or immediately after fertilization, progesterone begins to build up, but slowly over a 2, 3, 4 day period. And every day of that reproductive cycle, the normal hormone profile of that cow changes. The uterine lining of that cow also changes as the embryo progresses. So ultimately, what I'm trying to say here is that we flush embryos 7 days after the cow's estrus period. The embryos are about 100 cells at that stage and encased in a clear eggshell called a zona pellucida. Now, the embryo is recovered 7 days after the estrus period. It must go back into a recipient cow that was in estrus 7 days ago.